Good morning, dear students. Welcome you all to the next lecture of JC Connect series of online lectures. Please, any one of you give me the confirmation for the voice and the screen visibility so that I can start with the
Yes,
class.
sir.
Yes, sir.
Yes, sir. It's
Yeah,
visible.
fine. Yeah, thank you. So, we are studying the subject construction economics and finance, and we are into the last part of module 1, where we'll be studying interesting things, which is the compound interest factors. So this is the last part of your first module, wherein we'll be studying these compound interest factors and solving examples. So by this weekend, I think probably we'll be able to finish this module. I'll send you all the PDF notes and problems here we'll solve in the class. So firstly, we have to start with understanding what is simple interest. So generally we don't have any problems on simple interest, but still we should know what is simple interest. The interest is said to be simple when interest is charged only on the principal amount for the interest period. So simple interest is a basic calculation where we take an extra amount only on the principal. Okay. Whereas when we go to the compound interest, we'll be able to see that the interest is also charged on compound amount also, or the interest amount also. So simple interest is nothing but the interest which is charged only on the principal amount. Further, I have taken a small example which will make the things clear. In case of simple interest, the total amount of interest accumulated for a given period is a simple product of principal amount and rate of interest. So we did not break our head to find a simple interest. It is just the multiplication of P, which is the principal amount, N is the period or number of years, and I is the rate of interest. So that is what is we have simple interest. Simple interest reflects the effect of time value of money only on principal amount. So it is quite simple. Just I'm giving you all this definition. We don't use it generally. Everything what is done in banking, economics, and accounts is all based on compounding interest. So next, compound interest. It is the interest which we put considering your principal as well as the interest which is accumulated from the previous period. So the interest is said to be compound when interest for any interest period is charged on principal amount plus the interest amount occurred in the previous interest period. Compound interest takes into account the effect of time value of money on both principal as well as the accrued interest also. Now this last line here is very important. Okay, the last line which we'll see here is very important, that the compound interest takes into account the effect of time value of money both on principal as well as the accrued interest. This doesn't happen in case of simple interest. This is valid only for the compound interest, where compounding is done taking into consideration the interest amount of the previous year also. So simple interest means just we calculate the interest on the principal amount, as simple as that. Compound interest means we compute the interest on the principal as well as the interest which is there from the previous year. Now, when I take the example for this, the things will become much clear. Discussion with the example. A person has taken a loan amount of rupees 10,000 from a bank for a period of 5 years. Estimate the amount of money the person will repay to the bank at the end of 5 years for the following cases. So case 1 is considering simple interest of 8% per year, and the second case or case B is considering compound interest. So the definitions what we have studied just now will become much more clear when we take this example. So example is pretty simple here. A person has taken an amount of 10,000 from a bank for a period of 5 years. He has to pay that amount back, and while paying Now there are two cases. One is only simple interest is considered at 8% per year, and second case is compound interest is considered at 8% per year. Now let us see how things change. So first, I'm taking an example where I have simple interest at 8%. So as per the definition, simple interest is nothing but just multiplying 10,000 by rate of interest. Rate of interest is 8%, means 8 divided by 100 gives us 0.08. The interest for each year will be 10,000 multiplied by 0.08, which is equal to rupees 800. So interest for each year is calculated only on principal amount. As we are dealing with simple interest, we calculate interest for per year only on your principal, that is 10,000. So each year, that means you are getting 800, 800, 800 extra for the given period. So now this can be tabulated in this form. So say at the end of first year, amount of interest is 800. Total amount 10,000 was already there and 800 added up to it, means his loan amount now became 10,800. Second year also, as we are taking simple interest only, the interest is calculated only on that 10,000. So again, interest remains the same. So now this value here we are getting by addition of these both. 10,800 plus 800, we get 11,600. Then again for third year, what happens? Again, interest amount is 800. So again to this 11,600, we add 800 and we get 12,400. Now again at the end of fourth year, it is 800. Now this again 800 is added to 12,400 and we get 13,200. And at the end of fifth year, which is his term, again 800 will be added to 13,200 and he is getting the amount as 14,000. Means totally for a period of 5 years, if you consider, he will have to pay 14,000 for 10,000 rupees what he had taken. If he is taking the loan for 5 years, he will end up paying 14,000. Now this is the effect of simple interest. Simple interest, what did it do? The total amount of loan taken was 10,000 at a rate of interest of 8%. So 8% means per year it went on adding 800 to the amount, and the amount grew by 800 per year. This is how we go with simple interest calculation. So simple interest is easy, wherein only we consider the interest occurring on the principal amount. And as the principal amount is fixed, which is 10,000, we took a rate of interest of 8%. So each year the interest amount came out to be 800. So for 10,000, 800 went on adding. So at the end of 5 years, we will get an amount which is equal to 14,000. So for a loan of 10,000, if he uses it for 5 years, at the end of 5 years, he'll be paying out 14,000. So now same problem if we go ahead with compound interest. So now same problem I am taking into consideration compound interest. So now what happened? What was the definition of compound interest? Compound interest means we put interest on principal as well as the interest generated from the previous year. Okay, so this calculation will make it clear to you. So amount of interest accumulated at the end of first year. So for first year, what is happening? Amount is 10,000. We are multiplying with 8%, so we get 800. So total amount at the end of the first year is 10,000 plus 800, which is 10,800. Now this figure matches with your simple interest figure also, not an issue in this. But now in the second case, when you go for calculation of the interest amount, or here it is mentioned interest accumulated, we are not calculating the interest on 10,000. We have to calculate interest on 10,800. Now this is compounding. Okay, this is what is we say as compounding. So more number of years you go on using compound interest, the more amount will be paying. So now here we calculated the interest on not 10,000, but our interest calculation went to 10,800 and rate of interest was 8%. So multiplied. So now instead of 800 here, we got say 864. This is 64 is the effect of compounding. Okay, the 64 is the effect of compounding. Now, when we went for the next year, the amount was 10,800. And now on this, we are multiplying. Sorry, for this, we add this interest amount, and this is what we get, 11,644. So what happens is each year, the compounding amount goes on increasing. Now, when I put up this table, idea will be clear. Okay, so when you saw the simple interest table here, everything was 800. Okay, got the point. Here everything was 800. Now here what happens? For the first year it is 800 because the amount is 10,000. So this 800 adds up and the amount becomes 10,800. But when we come to second year, okay, when we come to second year, this 864 is 8% of this. Means this is multiplied by 0.08 and that becomes your amount. Sorry, writing with this is not that easy. This is multiplied by the 8%. Okay. So similarly now to this, again we add this and get this amount, 11,664. Now what happens at the end of second year? You owe to the bank 11,664. Now to this 8% will be multiplied and you get a number 933.12. Again add these both, so you'll get the amount which you owe to the bank at the end of third year. Now to this amount again you multiply 8%, so you'll get the amount of interest. Now it is 1,007.77. Add these both, you'll get the amount which you owe to the bank at the end of fourth year. And at the end of the period, that is the fifth year, this amount what we have, 13,604, this you got to multiply by 8%. 8% you multiply, you'll get the amount here. This is the interest. Add these both, you'll get the final value. Add these both, you'll get the final value. So what we observe here is when we go for compounding, in simple interest amount was only 14,000. But when we went for compounding, now we have an amount 14,693.28. So this 693.28 is the effect of compounding. Okay, 693.28 is the effect of compounding. So if this amount was given on 600, sorry, simple interest, that 693.28 would not have come in the picture. But as this amount is considering compounding interest, this increased by 693. So now this is the basic difference between simple interest and compound interest. Once again, I'll repeat. In case of simple interest, when we saw here, in case of simple interest, what was happening? The amount was constant. This was constant all the way because this 800 is generated by applying 8% on the principal amount. Other amount is not considered. So here also variation was uniform, which was in the terms of 800 per year. So this was first case of simple interest. We got a simple interest total answer of 14,000, means the person has to pay 14,000. Then we came to compound interest. Now what is the change in compound interest you observe here? This value is not same throughout. This value is not the same throughout. This value goes on increasing because the effect of compounding is taking place. How we calculate the amount of interest here? We don't take the principal amount, but we take the compounded amount. Okay, so what is the compounded amount in this case? This amount. So to this, when we multiply by 8%, we are getting 864. Okay, so this is how it happens. Then add these both, you'll get the amount at the end of 2 years. Now for this 11,664, we have to multiply the rate of interest to get the next amount of interest. Add these both, you'll get the total amount which is payable. So once we start doing this, we find that at the end of 5 years, which is our term, the amount is increased by 693.28. 28 rupees. Now this is how banks operate on the housing loans and all. The loan goes on compounding and compounding. Okay, and these amounts go on increasing. The higher the total principal amount you have taken, these interest amounts, then they distribute the interest throughout, and then they give you something called as EMI, which you have to pay monthly. So this is what is simple interest and compound interest. Now this basic is required to go further for studying the compound interest factors. So compound interest factors. The compound interest factors are corresponding formulae which are used to find unknown amounts at a given rate of interest for certain periods. The following are the notations which we'll be requiring. So compound interest factors are the different formulas which we'll be using while solving some easy examples initially. Further with time, the examples will get complicated. So these factors are dependent on the rate of interest and the period. And by using the formulas and the charts and the tables, we can easily find these answers. So now this part is very important. Simple interest and compound interest was fine, which was a part of regular thing. So now here your involvement will start. So first, discounting rate. Okay, we have studied about this. It is the rate of interest or internal rate of return and expressed in percentage. This percentage is generally same for entire investment period, but in some cases may vary. Now, what do I mean by this? I generally remains constant for the given period, but in some cases we see the things such that for first 5 years rate of interest charge is something different. For next 5 years the rate of interest charge can be something different. Now, if you have a floating housing loan, okay, there is something called as a repo rate which is changed at every quarter by the Reserve Bank, and based on that your loan EMI percentage, sorry, this rate of interest percentage varies, okay, for that particular quarter, and the EMIs gets adjusted. So that is how we say that the discounting rate or I value may remain same for a period or may change also. Now, what is a period? The entire term of investment is considered for calculation is the period. For example, if I say I am investing 5 lakh rupees in a bank and keeping it as a FD, so my period becomes 5 years. I am taking an education loan for a period of 10 years, so that 10 years becomes my period. So with each and every case, the periods go on changing. Now next, these three terms we have discussed, and they'll be very, very useful and important while understanding the problems. Present worth. It is the present value or present amount of any investment. F stands for future worth. It is the future value or future amount of any investment. And next is annuity. It is a uniform series of cash flow equally distributed over the entire period of investment. So annuity is a new word which is introduced. So it is the uniform series of cash flow. Now I'll give you all one example for present worth. So if I go to purchase a television, I have to pay 45,000. So what is the present worth of that television? 45,000. So the amount which you have currently with you, or you have to make a payment instantly, is termed as present worth. Now you have a sum of 10 lakh rupees with you, which you want to invest. So your present worth is currently 10 lakh. Next, future worth. Now future worth is a prediction. Future worth depends on market and rate of interest and all those other things. So future worth is an value which we will get either by investing the present worth or investing in the form of annuity. So if we invest as fixed deposit, now fixed deposit invested today is the present worth. I am making a fixed deposit of 1 lakh rupees for 5 years. So at present 1 lakh is the present worth, and after 5 years what I'll get will be the future worth. Now when we come to annuity, annuity is a uniform series. So what EMI we say, EMI, earnest monthly installment, that is something of annuity. Or say you might have seen postal RDs or bank RDs, you are paying it per month. That payment which is equally distributed throughout the year for the entire period is termed as annuity. Now we can take an example here that you are paying some certain amount to the bank in the form of RD. So RD you paid monthly. Say monthly I'm going on depositing 1,111,000 rupees, and I'm doing this for 3 years. So it will give me some future amount. What is my annuity? The amount which I'm paying currently per year is my annuity. So 1,000 rupees per month means 12,000 rupees in the year. So your annuity is 12. So you're paying this annuity for how many years? 3 years. And after 3 years, what you'll get? That amount will be called as future amount. So these are the three main terms: present, future, and annuity. So here we'll come across words such as lump sum. A lump sum amount is paid. Lump sum amount is paid means a whole amount is paid. So either a lump sum amount can be present, or you will get a lump sum amount means you'll be getting that in the future. So examples for lump sum amount will be deposit. I have to pay a deposit of 50,000 rupees. Okay, that becomes lump sum, and that has to be paid right now before taking the rented flat. So that 50,000 becomes the present worth. Then you pay the annuity, that is the rent. Monthly you go on paying, say rent is 6,000 rupees. So totally for 1 year you'll pay 6,000 per month. So 12 6 72,000 becomes your annuity. So remember, present worth is the current thing which you have or which you will be investing. Future worth is something which you will be getting in the future, and annuity is something which you pay regularly, year by year, year by year. So these are the three terms which will be very important when we discuss the problems. So now here you have a cash flow figure indicating present worth, future worth, and annuity. So Neha, are you there?
Yes, sir.
Yeah, looking at this cash flow diagram, can you tell me which are the inflows and which are the outflows? Can you just give me an overview of this cash flow diagram, if you can?
Yes, sir.
Yeah, please try.
So give me 2 minutes.
Okay. So whenever you start looking at an cash flow diagram, first two things you have to observe is the total period will be given in the cash flow diagram, which is very, very important. And next things to be considered are inflow and outflow. Okay, so always a cash flow diagram will have two components. One is the inflow of cash, means you are gaining. Second is the outflow of the cash which you are
So,
investing. Yeah, yeah.
sir, at the phone number, it is cash outflow.
Okay, no, no. Start from first, zero.
Okay.
First,
At
tell the
zero, it
term.
is
No, first you
present
have to
worth,
tell
sir.
the term.
It
Tell
is
the
present
term.
worth, sir.
Term is 10 years. Okay, see
Yes.
here, always, yeah, when you go to the cash flow diagram, the most important thing which you have to see is the term. Okay, so this is from 0 to 10. So this is first thing. Yes, now start Neha. So at 0, what is happening?
So it is the present worth. The
Yeah, it
amount
is a
is
present.
fixed from 0
It
to
is
1.
invested. Okay, it is going outflow. Okay, means at this point you are investing. Correct. Next, what is happening? Neha, able to hear? I think she has some network issues. Anyone else available will be able to tell me? Anyone else will
Sir,
be able to tell? Yes, Sayed, you can give a try.
uh, sir, the downward arrows gives the expenditure or cost, sir.
Yeah, expenditure, correct. Outflow. And
So
upward
then
arrow will
upward
give you
direction will give the benefit only.
benefit. Yes, correct. So now what is happening at 0 year? That is at start, we are investing something currently. So that is the present amount, which is your investment, down arrow, right? The next, how can you indicate this arrows from first to fifth year? Any idea? Now see here, what is happening is at the end of first year, you are paying some amount. At the end of second year, again you are investing something. Again at the third year, you're investing something. Fourth also investing something, and fifth also investing something. So this particular is the annuity, which is going in the form of investment. So here, uniform annual worth from end of first year to end of 5 year means again these are 5 investments which you are making. So with this cycle, you are expecting again a big investment here in the future. So this is marked as future amount. So for sixth year, you are gaining some amount. For 10th year, you are gaining some amount. So single amounts which you are getting in the future are indicated with this F letter. So these are all future amounts. So at the sixth year, you are getting some amount, and at the 10th year, you are getting some amount. At the initial stage, you are investing some amount, and at the fourth year also, you are investing some amount. So these are the investments. So this figure makes you clear what are the future worths, what are the present worths, and what are your annuities. So here your present worth is the investment which you make at the start, is at 0. Your future worth here are divided into two parts. At the end of fourth year, you will be requiring some lump sum investment. At the end of fourth year, you will be requiring some lump sum investment. That is your fourth year future value. At the sixth year, you will be getting something. Again, that is a future value. And at the end of 10th year also, you are getting something. That is again your future value. Then here you are getting annuity also is there in this figure, wherein from end of first year, second year, third year, fourth year, and fifth year, you are investing some constant amount. Now, if you take the example of your engineering course, okay, if you take an example of an engineering course or say architectural course, which runs for 5 years and study on this cycle. Okay, so at the 0th year means at the starting you are paying current amount. That includes the fees, okay, hostel fees and college fees, everything you pay. Then for first year, second year, third year, fourth year, every year you'll go on paying some fixed amount, which is the fees. Now, for fourth year, you might require some investment, say for taking a laptop or for taking something again. You imagine now at the fourth year, end of fourth year, when I'll be going to the fifth year, I'll require laptop and these all things. So for fourth year, you require some lump sum amount at that time, which you are thinking of now itself. So again, it becomes a future amount. So once you complete your course from sixth year, you will be earning. So those are your earnings. So sixth year, what is the future? You're earning. So what you earn again for next 3 years, you might do something, you might do nothing, or you might say that from seventh year I'm saving, and at the 10th year I'll have this much amount. So future amounts are the ones which you will be getting in the future, not presently. Present amount is the one which you have currently in hand, which you will be investing. And annuity are those amount which you invest equally over the entire period or the given period. So here annuity is running at the end of first year up to end of fifth year. So you can take it as fees. Okay, you can take it as rent. Anything which goes for one continuous cycle equally, we term it as annuity. So there are the three components: present, annuity, and future. So now based on this, we have this chart. Okay, based on this, we have this chart. Apurva, are you there?
Yes, sir.
Apurva, yeah.
Yes,
Can
sir.
you read the first row? Can you read the first row for me?
Name of the factor,
No,
single payment.
leave that. Yeah, single payment, correct. Single payment.
Yeah, single payment compound amount factor. So, I should read the full or row also, sir?
Full row.
Okay, so the abbreviation for that is SPCAF, and the formula to calculate single payment compound factor amount factor is future value divided by present value, and interest and number of years. With interest and number of years, we need to calculate it. And the mathematical expression is 1 plus I raised to n, that is 1 plus interest raised to number of years. Given so in this problem, future value will be, sorry, present value will be given, and we need to find the future value.
Yeah, very good. So
Yeah.
now this is the first formula. Okay, now Apurva, please. Yeah, thank you, Apurva. So this is the first formula. So now from here, all the interesting things start. Single payment compound amount factor, SPCAF. So when you know some present value and you want to compute the future of it, we use one factor which we term as single payment compound amount factor, SPCAF. So now here, this indication. Okay, so first term is which we need to find out, and second term is which is given. So this we read as future of present for given rate of interest and period. Okay, so how we read this? F/P means we need to find future when which amount is given to you, present amount is given to you. So how we calculate it? We calculate that using this relation, mathematical relation, 1 plus I raised to n, and multiply it by what is known to you. See here, to find out this column, 4 multiplied by 5. So P, which is the present amount, will be multiplied by this and we'll get the future amount. Okay, this is how we read it. Now, why the name single payment compound amount factor? So the name is given as single payment because we have present worth, which is a single amount. Okay, which is a single amount. So this is single payment. So when you are getting a single amount, either in present or future, it will be termed as single payment. Okay, now compound amount factor means this amount which you are investing today will go on compounding for the given period and you will get a future amount. Okay, so the name is single payment compound amount factor. Now, which formula we'll use? We'll use the formula 1 plus I raised to n. That has to be multiplied by the present amount. Now, the example for this is, I am keeping a fixed deposit of rupees 10,000 for a period of 5 years at rate of interest of 5%. How much I will get at the end of 5 years? Okay, so here present is 5,000 which you are keeping, future we don't know. So this formula we have to use. I have selected as 5% means 5 divided by 100. N is 5 years, multiply that by 5,000, you'll get the future amount. So these formulas are very easy. And to make the things more easy, we have compound interest tables, which we'll be discussing. So next, when we come to the second row, Vivek, are you there? Vivek?
Yes, sir. Yes, sir.
Yeah, please can you go through the second row and tell what we will be finding in this?
Yes, sir. The second thing is single payment present worth factor, and the
Okay.
abbreviation for that is SPPWF.
Okay.
Wherein the functional representation is present value by future value with respect
means-
to interest and number of years.
Right. Yeah. So 1 minute. This means we have to find present of future.
Yes, sir.
Okay. First, what is there? It will be unknown. Second will be the given value.
Given
Present of future. Okay.
Yes, sir. So
Yeah.
the mathematical expression for this is 1 divided by 1 plus I raised to the whole raised to n, which in the problem the future value will be given, and we have to find out the present value.
Correct. So this future value, thank you, Vivek. We have to multiply this. Now see here, this is just the reciprocal. Okay, this is just the reciprocal. Means in this case, what is happening is we have the future value and we want to find the present value. Okay, we have the future value of something, we got to find its present value. So here we do this thing, and this is called as again single payment present worth factor. So while finding this future value we have and present value, we have to find out. First case was present value was known, we found out future value. And now, for example, I'll say this land will be worth rupees 50 lakhs after 10 years. Okay, this land will be worth rupees 50 lakhs after 10 years. So then how much will be its present value? I can find using this. I'm purchasing a shop. Okay, it is at a market area. So down the line in 10 years, the rates will increase. I predict that after 10 years, the shop I'm purchasing today will yield me say 10 lakh rupees. So then what its value should be today. Now this will be taken into consideration when some business is taken over. Okay, this basically, because when we take over a business, it is not just a 6 months or 1 year commitment. They look into it, for say 10 years or 15 years. So they find out an approximate future cost, and then from that future cost they come back to the present cost and they make a deal. Okay, so when you sit for a deal, the negotiations happen. So for that negotiations, this SPPWF will be very important. That is single payment present worth factor. This factor will be very important when you want to purchase something which is giving you a lot of fruits in future. So you know that it is giving me good amount in future. Say it is going to give me 100 CR in future. So for that, I have to pay today something to take that particular property or a running business or industry. So today, how much I have to pay? So if your market calculations are correct for a period of 10 years or 20 years, you're taking, you take a rate of interest from the market, that is discounting rate, and calculate what will be the best possible thing which you'll be paying today. On that basis, these things will be done. So if I want to sell my existing building, okay, and person who wants to take, he'll not just keep in mind today what he's paying. He will take in mind that how can he use it, or he can keep that property for 5 years and again sell it off. How will be the growth of that property? So many people do it. They purchase some land, they keep it for 5, 10, 20 years, and after that they sell that land. Okay, because they will be having an amount in mind that after 10 years this land might give me this much money. What happens is that becomes the present value of future. So this will be very, very much important from your business point of view. Then next, who will read it for me? The third row. Anyone can read the third row for me?
So I can read.
Yeah, Neha, go ahead.
Sir, it is for uniform series present worth factor,
Okay,
and the abbreviation is USPWF.
okay.
The functional representation is given like present worth divided by the annuity
No, so again, it is
with
not divided
respect
by.
to.
1 minute,
So,
Neha, it is not again divided. Present is unknown. Okay,
okay,
first term is unknown. So P of A, that is not divided by, P of A means present worth of annuity. Okay,
sorry,
fine.
P.
Okay,
It's
no problem. No issue.
okay.
Hmm.
It's with respect to interest and number of period, and the mathematical expression is given by 1 plus I raised to n minus 1 whole term divided by I in bracket 1 plus I raised to n.
Hmm.
And here
Okay,
annuity is given, and we have to find out the present worth.
worth. Okay, fine. Very good. So annuity is given, we have to find the present worth. So anyone can give me the example how we can go, okay, what things we can analyze for this third row. Annuity is given, we want to find the present worth. Annuity is given, we want to find the present worth. Okay, so fine, I'll only give you one example. Annuity means annual payment. Okay, annuity means annual payment. So again, example of a recurring deposit or a postal RD comes here. So you are paying 500 per month. So such you pay for 5 years. So per year 500 means 12 months in a year. 12 5 are 66,000 rupees you are paying per year. So that is annuity. So you are going on paying. So at one point you find, I want to find the present worth. Okay, so you go with this formula. This formula will give you, if you are paying some annuity and the rate of interest is available, what will be the present amount you'll be getting. Now this will be very important if you want to cancel an RD. Okay, in a bank, if you want to cancel an recurring deposit, which is there for say entire year, 1 year recurring deposit you have, and at the end of 8th month you want to cancel it. Okay, at the end of 8th month you want to cancel that recurring deposit. So say you are paying 1,000 rupees per month, and at up to 8 months if you calculate, it will be 8,000. So are you getting only 8,000 back? No, because as you have paid that for 8 months, annuity is paid for every month for 8 continuous months. You will get some amount more than what you have paid. So if say you have paid 1,000 rupees for 8 months, actually you should have got only 8,000 rupees because you are withdrawing it. But no, compounding factor comes in and you get present worth of annuity. So if you have your banking apps in your cell phone, and if you have some RD, okay, if you have some RD and present worth of that, it will show. Okay, you go into the banking apps, you'll find an investment. If you have done an RD, their calculations will come. they'll directly show the answer, they'll not show the calculation. So now if it comes in months, n has to be taken as 8 months. If I say, it will be 8 divided by 12, because n we take in years. But if you want to calculate something for months and all, then you have to take. Now these all things will be very important, because if any investment you want to stop it, or at present you want to know its value. Okay, now you have an RD, you come across a money requirement, say your RD is big. So you are paying, say, 10,000 rupees per month. So in a year, you will be accumulating 1,20,000 plus the interest. But suddenly at the end of, say, 6th month or 7th month, you want some cash. So at that time, either you have a choice of taking from someone or making a loan, or you can think that if I break my investment, how much presently it will be worth. So you have paid 10,000 for 6 months, so it will be 60,000 plus something you will get, because you have followed the annuity pattern. So in that case, you can take the value. Which value? Given is annuity, which RD you are paying, and find P, means present worth of that annuity which you have invested. Okay, so that becomes important. Now next one is capital recovery factor. So anyone can help me out with this fourth one? Capital recovery factor. Capital recovery factor. Sachin, are you there? Sachin? Sachin, are you there? Atia? Atia, are you there?
Sir, I will
Atia,
read
are
the
you?
flow.
Yeah, please go ahead.
The factor is given by the capital recovery factor, sir. Abbreviation is
Yes.
CRF, and the
Okay.
functional represent is annuity of present worth with respect to
Yes.
IN, and the
Then correct.
mathematical expression is given by I into bracket of 1 plus I raised to n divided by bracket 1 plus I raised to n minus 1.
Okay.
The given P and finding A, sir.
Annuity. Okay. Very good.
Yes.
Nice. Now here, you give me one example, if anyone can. This many of us use it while shopping. We use this amount. Use this example. Anyone remembers that? So many times, if we have that Bajaj Finance option, wherein we purchase something and pay on EMI. Has anyone done that? Say a big thing, if you are taking fridge, television, we have that option in Amazon. Anyone has seen it?
Sir, I am paying, sir.
Yes, sir, I've seen it.
Yeah, you're paying. Very good. So now in that case, what happens is, now sometimes interest-free EMIs are available, or in some cases with interest EMIs are available. Now you are purchasing a refrigerator which is worth 45,000 rupees, but you don't want to pay that amount single-handedly. You don't have that much of cash. So what they'll tell you, pay currently, say, some percentage of it. Say out of 45,000, pay 10,000 as of now, and remaining what is there, that is 35,000, you can pay in the form of EMI, and this much will be the EMI they'll tell you, and you go on paying it. You can take it for 1 year and pay it off. Now that is what is annuity of present. So present means your amount is known to you and you will be taking an annuity. So always remember, if you go by compounding factor, okay, you'll end up paying more. So now what happens in our relatives, many times we give or take money from someone. So say if I've taken, say, a lakh of rupees. So what I'll tell, every month I'll go on giving you this much amount, so that at the end of 1 year, I'll be giving you 1 lakh of rupees. Now their interest compounding doesn't come into picture. But if you want to go ahead with the interest and tell them the exact amount, then this formula, that is capital recovery factor, has to be used, and this becomes very, very, very important. So some cases you might have this capital recovery factor without any interests. Okay, but in maximum cases, this capital recovery factor comes with an interest. Now, if you are using your credit card, so credit card bill comes. Again, it is the present. You have already done the shopping, but you have to pay an amount later. So these are all capital recovery factors. So this again is important for sales and purchase. means you know how much is the cost, but you are not paying that entire amount altogether. You are paying that equal part by part in the form of annuity. So that becomes capital recovery factor. Okay, means you are recovering the amount which already you have used. You have already got the fridge in your home, you have started to use it, but still you have not paid the entire amount. You are paying that amount point by point, part by part in form of annuity. So here in this case, present is known, you want to find out annuity. So the next one, next, uniform series compound amount factor. Anyone can explain me?
Yes, sir.
Yes, who is it? Yes, Vinay, please go ahead.
Yes, sir.
Yeah, go ahead, Vinay.
Sir, name of the factor is uniform series compound factor.
Okay,
Abbreviation is USCF, and functional
okay,
differentiation is F is to A.
okay,
Mathematical expression is 1 plus I to the power of n minus 1 divided by I, and given is A, and
okay.
to find out is equal to F.
Future. Yeah. So any example for it, Vinay, you know?
Mm, mm,
Okay, fine. Thank you, Vinay. Now, again, this same example is opposite of your this thing. Now, RD, you are investing 10,000 rupees, 1 lakh rupees per year. What you'll be getting in future? So it is uniform series compound amount factor. Okay, uniform series means why it is termed as uniform series given is annuity. Annuity is always uniform. Okay, annuity is always uniform. So wherever given is annuity, there the word uniform comes. Okay, wherever you have annuity, there the term uniform series comes in. So here what is happening? What uniformly you are investing is getting compounded and compounded and compounded, and at the end of your term, you are getting that answer. That is your future value. So now last is an important thing, sinking fund factor. Anyone will like to tell this? Sinking fund factor?
Yes, sir.
Yes, go ahead.
Sinking fund factor, abbreviation SFF, wherein we find the annuity
Yeah,
by considering the future value,
correct.
and the mathematical expression for this is I upon 1 plus I raised to n minus 1. The given value, future value is given, and we have to find the annuity. For
Annuity.
example, we can consider systematic investment plans as a good
Okay, great.
example for this.
Right.
Uh,
Correct. Yes. Thank you, Vivek. So now here, what here we need to find is future is given to us and we want to find the annuity. Now, what does this mean? We keep a target. At the end of 5 years, I want to purchase a car. Okay, so nearly that car will be costing me say 6 lakh rupees. So from today, let me start investing some amount per year. So at the end of 6 years, I have some good amount with me, and further, if required, I'll go for loan. So how much amount I should start investing? That is your annuity, because here you have kept an target. In future, I want to get something or purchase something which is worth this much. Okay, now these all many plans introduced by the current government. Okay, for the this girl child, one plan has come up. Every year up to the 18th year, you have to pay this much amount, and at the end of that, you'll be getting one future amount. So they have said that pay like 700 or 800 per month. Some small amounts are there which are paid every month. And when the girl child is of 18 years or say 20 years, or education wise also they have made the plans. Okay, this is what is something called as future is known, and we want to find the annuity. Now this SBI and all have these schemes, SBI Finance and all have these schemes where we have to go on paying certain amount, and at the end of 10 years, they'll be giving us a lump sum amount. That amount they'll tell us we'll be getting 10 lakh rupees after the end of 10 years. Today what you have to pay? You have to pay an annuity. So that annuity will be given. So this is called a sinking fund factor. Okay, this is called a sinking fund factor. So these 6 things are there. The main thing is, if you remember 3 formulas, other 3 are inverse of it. If you look at the table carefully, what you find is one formula is reciprocal of the other. So that is one good easy thing. So only you have to see what is given and what you have to find, and the sums are very, very, very interesting here. So The terms you should read properly, should understand. Now, when I say a deposit is paid, okay, if I am saying that I have paid a deposit, what will be that amount? Is any one of you? I'll say that I have paid a deposit. Okay, I have paid a deposit. So it becomes which amount? It becomes a present amount. So they'll not write there the word present with that English what they have given. You have to understand whether the amount is present, whether the amount is future, or whether the amount is annuity. So with this, I'll take up a very easy example where we have to apply this formula, and I'll also teach you all parallelly by using compound interest tables, which I'll share in the group, how we can solve this. Now, this is the basic thing, these things. Now, in this one, two derivations are rarely asked. Derivations also, PDF I'll share. Anyone wants to discuss, I'll discuss those derivations with them. So, example. A person is investing a sum of 75,000 every year for a period of 8 years in a recurring deposit. What is the amount he will get at the end of 8 years if the rate of interest is 10%? Okay. Ravina, are you there?
Yes, sir.
Yeah, please can you tell what is given and what we have to find? It's quite easy.
So investing amount is the present worth, and they've given us the period that is 8 years, and interest I is being given that is 10%.
Okay.
And they have asked for the future worth.
Future worth. So investing amount is here annuity or present worth?
Present worth, sir.
No, 1 minute. A person is investing a sum of 75,000 every year.
Now so it is annuity. It's annuity every
annuity,
year.
Yeah, every year. Yeah, this is what. Thank you. Very good. So now this has to be taken into consideration. And what first you said, that is the eventual mistake I've seen many students doing. So when you see an amount, you feel it is a present amount. No, you have to read the line. So what it is doing, the person is investing the sum of 75,000 every year. So what is annuity? An equal payment made over a particular period is termed as annuity. So here 75,000 is the annuity. So he's paying 75,000 per year for how many years? Period is 8 years. That is n is equal to 8 years. And the rate of interest is how much? 10%. So now here, if you go to the solution, part, investment. Now investment is in the form of annuity. So be careful because here it is mentioned every year, and that investment is 75,000. So now period. What is the period? 8 years. N is 8 years. Now interest rate is 10%. So we don't know the future amount. So here in this case, we need to find future of annuity. So here in this case, we need to find what? Future of annuity. Now when we say future of annuity, that means annuity is given, we need to find future. So if we go back to the table, so which is the formula which we'll have to use?
Sir, first formula only, sir. P into 1 plus I raised to n.
Is it correct? Given is what?
So no, the uniform series compound amount factor we are supposed to use.
Yeah, second last formula we have to use. Shahbaz ji, यहाँ पे हमको annuity दिया है. Yeah, second last. Shahbaz, understand? Okay, annuity is given. Okay, so if it was lump sum amount, okay, present first. But as here annuity is given, and we want to find which value? Future value. We have to use which factor? USCAF. Okay, means to this we have to multiply with A, and it is 75,000. So I will be how much here? I is given as
I is 10%, sir.
10%, right? So I is 10%. So see here how the substitution goes. 75,000, which is the annuity, which is given here. 1 is as it is. I don't take it directly 10. Okay, because 10% is, so 10 divided by 100. So 0.1 raised to 8 minus 1, again entire divided by I, which is 0.1. Okay, so when you use this formula, you get the answer as 85,700 and no, 8,57,691. So here what we did, we found out future value of a annuity. Annuity is the sum which you are investing every year. So in this particular case, the person has invested this sum for 8 years and the rate of interest offered was 10%. So we use that formula and we found out. Okay, so you have to be careful and you have to select the formula. Which formula you are using is very, very important. Here we use the second last formula, which is future of annuity. Now, there is an easy method found out. Instead of remembering all the formulas, instead of remembering the formulas, we can refer something called as financial tables directly, which I'll show you all. Okay, which I'll show you all. So now here I've downloaded these financial tables, which I'll share it with you all. And this one print, you can keep it with you and get it attached so you can use it for the exams. So this is the end of period compound interest tables. Online, various tables are available. If you find something better than this also, you can share in the group, not an issue. If you type in Google compound interest tables, you'll be getting these tables. I'll share these tables at the end of the class with you all. So here, left corner and right corner, they mentioned the percentage, that is the I value. Okay, and here the period is given, and from 1 up to 480. Now these all become huge when you go for say 20 years of loan, 30 years of loan, okay, or beyond that these periods come into picture, or say for 100 years lease is given. So we don't require this much. Okay, our calculations will be hardly up to say 20 years. Okay, so now this thing we have to check first. So in our case, rate of interest is how much? 10%. So just scroll till we get to the table of 10%. See, here the percentages are changing. Initially, they have given it detailed 1.52. So further 4, 5, 6, 7% starts. Okay, so our table is this. So be careful while selecting the table. So this is the table, 10% table we want to refer. Then come to this N column. How much is our period? Which is our period?
8 years.
Yes, 8 years. Okay, is it clear which table I am referring? 10% wala table. I am coming to what? 8 years. Now, these are all the things which we need. So here what we are computing? Future of annuity. So see here, F by P, P by F, whatever we discussed, all things are here. We don't require this class. Arithmetic gradient, we don't require it. In our case, we are not going to that level. So these factors 1, 2, 3, 4, 5, 6 we are getting. So in this case, what we want to refer? Future of annuity, because that person is paying 75,000 rupees per year for the given period of 8 years. So we want to find this factor. So now for 8th year, come in this row exactly. Come in this row and say we get this factor. Okay, for 8th year, which factor we wanted? The compound amount factor, F by factor is 11.436. All of you who are present here, did you get how to read the table? Ravina, understood how to read the table?
Yes, sir.
Yeah, it's quite easy. It's not difficult. Only you have to be careful when you select which component you have to take. Now, this factor I'll use directly to find my answer instead of formula, 11.436. If I go here, see, referring the, this is what we have done earlier. Now this part is referring the compound interest table. For what value I used? I use this compound interest table for I is equal to 10 and N is equal to 8. So uniform series compound amount factor. This I directly got from the table as 11.436. So once I get this directly, I am multiplying it by annuity and I get the answer. So a bit of variation is there because this goes in detailed calculation, and if you increase again 2, 3, 4 digits, you'll get the exact number. But this is okay. So we got the answer as 8,57,700. So here we had the answer, same 8,57,691. Instead of 691, rounded up to 700. So you have two choices in the exam. Either you can remember the formulas rightly and get the answers, which very less people do. Or what you can do is directly you can go to the table, okay, see the number of years, see the percentage, and get the factor which you require, substitute that, and you can get the amount easily. So I think we will go with the problems referring to the tables, right? Because every time remembering the formula, if you miss something in the formula, it will be difficult. But still, for knowledge purpose, it's better that you remember the formulas also. And what happens is sometimes it's say it's 8 months, 9 months, such things are given. You don't find these in the tables. Okay. So once it had happened, like investment of 8 months only, it had been given. So at that time, n is equal to 8, you cannot take because n is in years. So that time you have to divide 8 by 12 and take it. So that time your formulas will be required. So only three formulas you have to remember. They are reciprocal of each other. And this is how we'll refer a table. Okay, so now if you have a pen, a paper, as I told, and a calculator with you all, what I am doing is, okay, in this example itself, what I am doing is this amount, okay, annuity amount, I am changing this amount to say 1 lakh. Okay, I am changing this amount to say 1 lakh. I am taking a period of 10 years. I am taking a period of 10 years. Okay, I'm taking a period of 10 years and interest rate I'm increasing to 12%. Same thing, annuity I'm taking 1 lakh, annuity I'm taking 1 lakh, and the period I'm taking n as 10 years and rate of interest I am taking as 12 years. Okay, use this formula and get the answer. All of you all, I told to keep a calculator and pen with you all. Hopefully you have it. Use the same formula. Now NAT instead of 75,000 is 1 lakh. N instead of 8 is 10. And I value instead of taking 0.1, that is 10%, you have to take 0.12. That is the change. I'll give you all 2 minutes, 5 minutes. Please work out and tell me what will be the future value. Then we'll go to the table and check it.
So 1,75,480 something.
Um, 1 lakh.
Yes, sir.
75,000. Sorry, 17 lakhs.
That's what, 17 lakhs
54,873.
873. Shabaji, correct hai?
Yes, sir. 17,54,873.50 paise.
Yeah, okay, very
17
good.
lakh 54,873.5.
Yeah, correct. Right. So now we will cross check this value with the table. So now when we go to the table, what we have to refer? Apurva, you tell me when we go to the table what you have to refer, or anyone else is there in the meeting available who has not answered. Yashoda, are you there? Yashoda? Atiya, are you there? Atiya is also not there. Naveen, are you there? Naveen?
Yes, sir.
Yeah, now help me out with the table. Which table we have to refer, you will be telling me. Okay. So n is 10 years, I is 12. Okay. So I'll open the table. So first, what I have to check?
Sir, rate of interest, sir.
Yeah. So this table, right?
Yes, 12%, sir.
Yeah.
This one, sir.
12%. Yes. Now next, what
Num
I have to check?
and number of years means period,
Yes.
sir.
Period. So here in my example, period is how much?
10 years.
10 years. So which factor I have to see? Future of annuity. Correct?
Yes, sir.
So what is the number?
So
17.549.
yes, sir.
That multiply this by 1 lakh, you will get the
Yes.
answer directly.
1,17,549.
549. And you have got how much? 1,54,873. Here
Yes,
you'll
sir.
get sorry, 17,54,873. Here you will get 17,54,900 something. Yeah, 900 something. So small variation will come because this is a rounded off factor. Okay, all of you take this factor, multiply and see. Multiply the 17.49549. This is the factor. So I think all of you will get the right answer.
So 17,54,900.
900. Whereas with the formula it was 873. So that is fine. Okay, because the formula will be rounded off. So guys, this is how, now this was single example. Now in one example itself, we'll get to use all these 2-3 components. Now these examples will take up from the next class. So once you are good with this part, next class will become easy for me. Okay. So now just note down this problem. Apurva, are you there? Apurva is not there. Okay. So Neha, can you tell me in this problem now, which is there on your screen, what is given and what needs to be done?
Yes, sir.
Yeah, please tell.
So there is nothing on screen.
Yeah, it's
Okay, now
coming.
clear.
Huh.
So I have to read the problem, or I have to
No,
just
no,
tell?
tell what is given, what is to be, what you need to find.
Yes, sir. Sir, here it is asked that annuity is asked, like
Okay,
person, sorry, which amount the person should invest every year, that is annuity,
okay,
and in order to get amount of 50 lakhs, that means it is the future worth.
correct. Very good.
And
So yes,
sorry,
it is 10 years and 8%. No
yes,
problem.
sir.
Correct. Yeah, yeah. Thank you. Very good. So here it's a reverse example where what amount a person has to invest every year in order to get an 50 lakh at the end of 10 years. Means here we have to find annuity where future is given. Okay, we have to take annuity and future is given. Just please note down this thing. Amount expected in future. Okay, that is F, amount expected in future. F is given. Amount expected in future is 50 lakhs. Investment annuity is question mark. Period is 10 years. So here we need to find annuity of future. Okay, here we need to find annuity of future. So annuity of future means, शाबाश अभी बोले कौन सा फॉर्मूला करेक्ट बोलो अभी.
सर यहाँ पे सर फ्यूचर अमाउंट दिए सर, हमें ये फाइंड आउट करना सर.
वही
मतलब
टेबल में कौन
इसका फॉर्मूला है सर.
कौन सा फैक्टर
सर टेबल में सर सिंकिंग फंड का आता है सर.
Correct. Very good. Last factor, sinking fund factor. Okay. It is the reverse of what we used in the previous. So that formula multiplied by the future amount, which is 50,000, will give you the answer. So please try and work out. Okay. So what we'll do, annuity A is equal to future into that formula.
Sir, 3,45,148.
3,45,148.
148.
यस सर करेक्ट है सर.
Correct है?
Right answer, sir.
Correct answer 3,08,000. Okay. So now fine. I'll not do this exercise here. So now this amount again we can go and find from the table easily where we don't want to remember the formula. So which table I have to see? Which table I'll have to see?
8%, sir.
8%.
8%. Yeah, 8% on the table. So all those things, if you go to a bank manager and ask them if this is the loan, this is the interest, they put one in one software and tell you. Those softwares are all based on these tables. So 8%. Okay, so 8%, and my period is how much? 10 years, right?
10 years.
Now tell me which column I have to see. First, second,
A
third,
by
fourth.
F, sir.
Fifth column.
Sir, third
Fifth
one,
column.
sinking fund.
Third one. A by P. No, this is present values. We want future value, Neha. Sinking fund is mentioned here.
Sinking
Okay.
fund.
Fifth column, sir.
Fifth column. So how much is that value? 0.0690. Okay. Sinking fund 0.0690. So you multiply. So you multiply what? 50 lakhs by
3,45,000.
सेम आया आंसर दोनों केस में.
हाँ सर, थोड़ा वेरी होता है सर बस.
हाँ, थोड़ा वेरी होता है, but the main amount will
Little
remain the same.
variation, sir.
Yeah, little variation. So how much you had got with the formula?
3,45,000, sir.
3,45,000.
Yes, sir.
Okay, and with the table?
3,45,147.
Okay, 45,147. 45,147. So this is how it works out. Okay, so I've taken simple examples here, wherein you have to find only one thing, okay, at one time. So further, we'll have problems where you'll be using different things. Okay, in one formula, one problem itself, you have to take 2-3 components and we have to solve. So that needs proper this thing. So I'll share the table with you all. Okay, and if possible, some few this easy type of examples also I'll share with you all so that you can try from your mobile phone only. You can open that table and check the values and you can give it a try. So hopefully all of you who are present, which started with 12, ended with 6, now 4 are remaining. You have understood today's class?
Yes, sir.
Sir.
Yes sir.
Yeah. So this was the basic class for your problems which will be solving. So if you don't know this thing, solving problem becomes difficult. Okay. So in the next class, we'll be starting with the problems, complete problems. Till then, what you do is just go through these tables and keep. Okay, so if maximum of you, I think you are using a laptop. So when we are solving the example from the group, you can open the table in the this thing, your mobile phones, so that we can solve the examples. And if you are attending the classes on cell phone itself, then it's fine. You can minimize it and check it. Not an issue. Okay. So with this, I'll conclude my today's class. All of you put the attendance with your name and USN, and you can leave the meeting. Thank you all. Have a nice day and a great week ahead. Thank you.